Namaste students. Today's concept is computational thinking for grade 5. Chapter 2, Fractions continued. Our first question, if each row follows the same theme, what will come in place of A and B? A and B, okay, it's here. A and B, the last fraction. It's a fraction, great. Let's understand the concept first. Here it is 1 by 6, 2 by 6, 3 by 6. Let us, equalize the denominators. Is that okay if I go with 2? So that becomes 4 by 6. Great. Here all of 4. Let me go with, okay, 2. Either you say find LCM or find the equivalent fraction. I'm going with 6 over 4. And here I'll go with 5, which is going to be 5 over 10. Great. I guess I have the concept. I understood the pattern here. Great. Coming here. 1, 2, 3, and you see it's 4. 3, 4, 5. Obviously it's 6. 2, 3, 4, and it's 5. So 5, 6, 7. The value of 8 I expect to be 8. Great. For now, I go with option A. Wait a minute. Here it's 12, 12, 12. So this is 12. B is 12. But But option A is not the right answer because as you see, the shaded portions are in simplified form. So they expect us to simplify these two numbers. So I go with 4 twice and 4 3 times. So the value of A is 2 and the value of B is 3. So I go with option B. Option A is also correct, but it is not in the simplified form. So we go with option B. Great. Moving on to the next question. Which of these options can we conclude from the following statement? I repeat, which of these options can we conclude from the following statement? Statement is 3/4 of total coins that Kiran has are of denomination 5 rupees. 3/4 is of 5 rupees. Okay. All coins that Kiran has are more than 2 rupees. How can we know? Still 1/4 of the coin is left and we have no idea about it. Maybe 1 rupee coins or maybe 2 rupee coins. We can't mention it, consider it as more than 2 rupees. Option B, all coins that Kiran has are of less than 10 rupees. Still, we have no idea. Only 1/4 of coins with Kiran are not 5 rupees. This is perfect because 3/4 are 5 rupees. Then 1/4 are not 5 rupees. In that case, I go with option C. Moving on to our next question. Sam makes 3 cuts on the same apple as shown by the dotted lines in the image below. Altogether, how many pieces of apple will he have? Great. If he's making the first cut, obviously we will have 2 pieces. That's half over here and half over here. And he makes another cut that becomes 4 pieces now. It's kind of 2 pieces. Then he makes another cut. So it's going to be 1, 2, 3, 4 pieces. And that 4 pieces is cut into half. So obviously it's going to be 8 pieces. Such a simple question, isn't it? Great. Moving on to our next question. If you take 6 times of me, 6 times of me, you will get a whole and a half. A whole and a half. If you take me out of whole, you are left with 3 times of me. Who am I? If you take 6 times of me, you will get a whole and a half. If you take me out of a whole, you are left with 3 times of me. Okay. Okay, this is a whole, this is half. we'll do one thing, 6 times. So this can be divided by 4 and this can be divided by 2. So it's totally 6 times, isn't it? Dividing 1 by 4, obviously it's 1/4. Dividing half into 2 parts, that is again 1/4. Each part is 1/4. So I go with quarter. I go with quarter. So the number is quarter. 1/4. 6 times of this will give you 1 by 2. And from 1, if you minus 1/4, that is take away 1/4, the remaining is 3/4. 3 times of me. Great. So I go with option B, the quarter. Great. Moving to our next question. In a chocolate shop, 4 buyers come in one by one to buy chocolates. Each buyer purchases half of the chocolates that are currently in the shop. Oh, great. I understand. Like if there are some chocolates, the first person will come and purchase this half. The second person will purchase the remaining half. That's actually quarter. And the next person comes, he purchases half of the remaining. And the next person comes, he purchases the half of the remaining. Okay. I drew this because we saw 4 buyers. So this is first buyer, second buyer, third buyer, and this is fourth buyer. Great. For example, if there are X chocolates initially, the first buyer buys half of the chocolate. Yes, X by 2 is for the first person. Then from the remaining chocolates, the second buyer buys half. That is nothing but half of the remaining, which is mathematically X by 4 for the second person. The third person would be X by 8, which is half of the previous person's, that is remaining. So obviously the fourth one will get half the thing, half of remaining, that is X by 16. This process continues until the fourth buyer, who buys only one chocolate. The fourth buyer buys one chocolate. Okay, that means X by 16 is equals to 1. Then the value of X is, by transpose rule, it is 16. Then I go with option C. Great. Moving on to our next question. Given below is a set of 8 cards, each having a whole number on it. Cards A, B, C, and D represent numbers that are either 1 more or 1 less than the number on the card directly above them. If all 8 cards on these cards are different, what is the sum of B and C? I repeat, if all 8 numbers on these cards. Great. I heard like, me saying cards on these cards. Great. Coming back to the question. So here I have 1. So A can be either 0 or 2. That is 1 more than the card above it or 1 less than the card above it. So we have two options. A can either be 0 or 2. B cannot be 3. It's going to be only 5. Why not 3? Because it's already used. Great. So I fix B as 5. The value of B is 5. And C, it cannot be, okay, since here it is 6, it can either be 5 or 7. But again, it cannot be 5 because 5 is already used. In that case, I fix the value of C as 7. And D, it cannot be 4 because it's used here. So obviously it is 2. Then the value of A is 0. The question is, what is the sum of B and C? And students, I want you to comment your answer for this question. Thank you. We'll meet in the next class with next set of questions.